Hey guys, so let's talk about quantum computers. So, why do we have quantum computers and why do we even care? So, let's say I have a situation where I have a baby elephant and it wants to meet its mother. Now, it has around 100 ways to reach its home. It definitely would want to choose the shortest path. When I try to find out the shortest path with a classical computer, it will check the 100 paths one at a time. So if it takes 1 second to check one path, it would in total take 100 seconds to find out the shortest one. Now when I tried the same problem with a quantum computer, what it would do is it will check 100 paths all together at a single time. So as a result, we'll get the answer, we'll get the shortest path in just a second. This is because it has enormous amount of parallel processing power, and this is why we need quantum computers. This is a very cutting edge stuff and it is super cool. Let's have a look at how quantum computers differ from that of a classical computer. The first point of difference is already been talked about in the previous example, that if it has to check 100 combinations, a quantum computers would do it by checking all the 100 combinations together, whereas classical computer would do it by ruling them all out individually. Other differences are like in a classical computer, a bit is a basic building block. Classical bits stores information as 0 or 1, whereas in a quantum computer, quantum information is stored in a qubit. And a qubit is a quantum mechanical analog of a classical bit. So it has the value, a qubit has the value 1 or 0 or both, because qubit is in a superposition state of 0 and 1. That is 0 and 1 both at the same time. So what's superposition? Superposition is like spinning a coin. When the coin is spinning, we don't know if it's either head or tails. We only know it when it stops and we measure it. And it's one of the things that makes quantum computers so powerful. Superposition is needed because I must tell you that in nature things just aren't this or that, they are uncertain. When you go down to a really small scale, things start to get weirder. Quantum computers are really good at handling this uncertainty because a qubit allows for uncertainty. And so it follows some principles of quantum mechanics like superposition, entanglement, interference, and many more. Alright, so let's take a look at benefits of quantum computing. It will be incredibly useful for cryptography, then particle physics, biology, especially in chemistry for molecular modelings. By using it, it will be easier for us to find a cure for cancer. It will be useful in data security, encryption, and lot more things like that.